Hi everybody and welcome to this Python tutorial. We're going to be estimating value at risk via a variance-covariance matrix method. So there's a few steps in this, and the first step is to navigate to this page, which I'll link in the description. So this is to download stock data now. I'm sure, as a lot of you are familiar with, it's very difficult to find an API for stock data now that's free and easy to use. So this is my best workaround for now that's free and all you'll be able to use. So it's called Fix Yahoo Finance, and the way I'm going to install it via Anaconda is I'm going to go to the Anaconda. Oops, I don't want that. I want the Anaconda prompt, and I'm just going to type in pip, or actually conda install fix underscore Yahoo underscore finance. And if I were to install it via pip on the command prompt, you would just use the instructions provided here on this page. So using this line right here, and again I'm going to link this in the description. So once you've done that, I would just copy and paste this over into whatever IDE you're using. I'm using Spider and Anaconda because I felt like this would be a great visual tutorial. Anaconda is great at being able to visualize variables, which is so valuable, especially when you're analyzing data like this. So what I did right here is I went ahead and arranged an array, or an array of tickers, and I also downloaded the data right here. So what this method basically, or I shouldn't call it a method, what this script so far does is simply get stock data, and the way it does it is it just web scrapes the Yahoo API or Yahoo page basically to get this stock data. So that's how it kind of works. And make sure when you do it, you're using the close key right here, because you're not going to be able to download 4 stocks worth of data. I'm going to add in one more just to show you guys that it works. I had Visa twice. I don't know why I had that. So we'll do General Electric, and I'm going to execute all this code. If you're in Anaconda, Control E. If you select a block of code, you'll be able to execute it. Really easy, really simple. And we have our data frame prices here. So the next step, which you're going to want to do, and I'm going to comment this out sort of well. So this will be step 1, get data. The next step is we want to convert this data frame into a returns data frame. So we're going to calculate the periodic returns or daily returns for all of these companies, and it goes up to, let's actually import date time for this. It's a library in Python. Okay, and what we're going to do, we're going to get some more data to work with here, because that's not enough to work with, I don't think so. dt.datetime.today. And let's see, okay, we have about 331 days worth of data. That's a lot better. So you can see this workaround with the Yahoo API works pretty darn well. So let's start. We're going to calculate returns next. So returns equals data.pct underscore change. And we're going to run that. And we have our returns data frame right there. So let's just print returns.head. See what we got. Awesome. So we're actually going to next we can generate a covariance matrix. I don't think we have to remove the not a number row. We can do that though, but I don't think we need to do that. If we generate the covariance matrix, I don't think that's going to matter. So generate covariance matrix. So really easy in Python. So I'm going to assign this to a variable, covariance matrix equals returns.cov. And cool, we have our covariance matrix. Awesome, with all our returns. And again, typically you would remove the first row by using something like na omit or remove NA, and that will work like that, but I really don't think we need to in this circumstance. Next, we're going to calculate the mean for each stock, and we're going to need that to eventually come to our portfolio mean. So the first thing we're going to do, and this is a really simple line of code, all we're going to say is average returns, we'll assign it to a variable, equals returns dot mean. Awesome, we can take a look at that too. So we have our average returns for each stock. We could annualize these figures as well, but again, not necessary for the sake of simplicity. So next, we're going to calculate our portfolio mean. And the way we're going to do that is pretty simple. All we need to do is take or generate weights for each stock. So let's say we have 5 stocks and we'll allocate 20% in each. So I'm just going to type in a vector 20% in each and make sure that line is ran, or executed rather. And so the way we're going to calculate the portfolio mean is by multiplying this array of weights, essentially transposed, and multiplying this array of average returns. And these returns are actually in a data frame. Excuse me, that's not the right one. This is actually a series, a pandas series, so we have to do some transposing. So what we're going to do, and it's really simple again in Python, is let's call it port underscore mean equals average returns, and then we're going to use .dot, which is going to transpose our array of weights, which we must do. And just to give you guys an idea of what we're doing here, awesome. Here's our portfolio mean. So just to give you guys an idea, because some of this might be a little difficult to understand if you're seeing this for a first time, or you're using this tutorial as a project for a class or something like that. So it's the same thing as basically saying some product, and if these are the arrays, or this is the array of weights per se, and these are the average returns, it's the same thing as that. The only thing that's different is we're just transposing these weights, because in Python the weights are in a different format than the returns. So basically we're flipping them from being like this and now being like this. I don't know, that might help you all out in understanding the sort of the math and understanding why this line needs to be executed. You can't just multiply them straight up. So the next step is to calculate the portfolio standard deviation. This is a little more difficult. Okay, so we're going to assign it to a variable port standard deviation. Okay, and that's going to be equal to the square root, and I'm going to go over this in Excel because these formulas are a little lengthy, and I think it's beneficial to everyone to understand it. And I also have to import NumPy. Most of my tutorials are also not scripted or drawn out before, so I pretty much just do this all off the dome, so bear with me as per usual. So we're going to square root the weights transposed, and then we're going to do some matrix multiplication after by the covariance matrix that we calculated, and then again by the transpose of the, not the transpose, excuse me, multiplied by the weights. And let's run this and see what we get. So we have a list object which can't be transposed, and the reason being is because this is not a NumPy array. So what I'm going to do is convert this weights array into a NumPy array, and that's very easy. Okay, so we have our portfolio standard deviation now. The next step is to calculate on an investment stance. I should probably put this up here. There we go. So we want to define an investment. So let's say, investment equals 10,000, or let's do $100,000. So we want to get these terms into dollar figures to calculate value at risk, because again, value at risk is the maximum one day, or it could be defined as a different frequency as well, the maximum loss over a pre-specified time frame on any sort of asset or portfolio. So what we want to do is, so for the mean investment calculation, that's going to be equal to 1 plus the portfolio mean times the investment. And we also need to calculate the mean standard deviation. Or volatility, if you will. And I'm just going to calculate I'm just going to use that, and I'll actually instead of calling it the same variable, I'll call it a standard deviation investment. Let's get that into dollar amounts, and let's see what we have. So that seems about right. The mean investment, that sounds about right, and we have a standard deviation as well. So we are close to calculating our value at risk metric. So what we want to do next is establish almost, if you're familiar with, I'm going to bring this up, the Gaussian distribution. In Excel and a lot of other programs that are super simple, we can calculate or actually choose a confidence level. And if we sorted our returns in ascending order, we could pick a point in the distribution of returns where we would establish our cutoff point. And essentially we're doing the same thing with this next formula, just to make this as simple as possible. I know this tutorial is probably going to be a little long and I want to keep it short. So let's establish a confidence level. And we're going to say, let's do the 99% value at risk, so 0.01. Okay, and the next step is to import, we're going to use a SciPy for a library. So from scipy.stat import norm, run that. And we're going to establish a cutoff point. So cut equals norm.ppf. So what this is going to do is sample from the normal distribution that would result that we would normally make in any other sort of application. So it would be the normal cumulative distribution that we'd be sampling from. So we're gonna, for our probability, we're gonna put our confidence level. Don't worry if you don't understand these formulas yet. And we're also gonna put a mean and a standard deviation in dollar amounts. Okay, and we're gonna calculate. Run this all over again, and let's see our cutoff point. And it's always going to be lower than our portfolio value. So we have $97,000 and $97,866.15 just about. And we can calculate our value at risk now, actually. So this will be our 1 day value at risk. So VAR_1D is going to be equal to investment minus cut. And I'm just going to comment this out. Okay, and we can check out our value at risk. I'll print it out actually. So it's approximately $2,133.85. So that looks about right. So that would be the way to calculate our 1 day value at risk. Now, you can also estimate this over different frequencies as well. So the way you would do that, if you want to estimate the 10-day value at risk or 20-day value at risk, we can actually do a for loop to check. So let's say num underscore days equals 50. Okay, we're going to say for x in range 150. What we can do is say we're going to print. We'll actually calculate our formula first. So all we do to estimate whatever n days of value at risk we're looking at, we can say var underscore 1b times the square root mp dot sqrt, we can use that, of x, and that's all that you really need to do. You just need to multiply by the square root of the number of days you're looking for. So we can say print, we'll say x, or the string of x, plus day, var, or var, and then plus, and we're probably going to need to do some string formatting for this to round it up. So np dot round, and you'll see why. 2 decimals, and we'll convert this to a string also. And we can check if that works, and we should get an output. Awesome. So our 50-day, or we should actually say this is exclusive of 50. So really simple fix is just putting in 51. I don't know why I did that either. I didn't even put the variable in. Awesome. So our 50-day value at risk is $15,088.60, and our 1 day value at risk we can check is the same, $2,133.84, just about, or 85, excuse me. So yeah, that's kind of the way that you do it, and it's very simple using Python. If we used Excel, just think we'd have to get all the data in and do all the calculations ourselves, but this is just a very simple way of doing it in Python, and this is just an overview on how to calculate value at risk via the variance-covariance method. And if you guys have any concerns or comments, please leave them in the comment section, and have a great day. Bye-bye.